Imagine this, you're holding a glass of water. It's so ordinary, so simple. Yet within that water are billions upon billions of invisible particles working in perfect harmony to make it what it is. How do we know this? It's thanks to a groundbreaking idea set forth in the early 19th century, the atomic theory. And its origin lies in the brilliant mind of a man named John Dalton. So, who was Dalton? John Dalton was an English scientist, a chemist, and a visionary. In 1808, he published a book titled A New System of Chemical Philosophy. Within its pages, he presented a theory that would change how humanity understands the very building blocks of matter. Until then, the idea that matter was made up of tiny, indivisible particles, atoms, was just speculation, tracing back to ancient Greek philosophers like Democritus. Dalton gave this idea scientific footing. Dalton's atomic theory was built on 4 key concepts. Let's break them down. First, Dalton proposed that all matter is made up of tiny, indivisible particles called atoms. Sounds simple, right? But think about it. This was an era when microscopes couldn't reveal the microscopic world in detail. He wasn't seeing atoms. He was deducing their existence through reasoning and experimentation. Revolutionary. Second, he stated that atoms of any given element are identical. That means every atom of hydrogen has the same properties, the same weight, the same structure. But atoms of different elements? Completely unique. That's why hydrogen behaves differently from carbon and why gold is, well, gold. Third, Dalton claimed that compounds are formed when atoms of different elements combine in fixed ratios. Picture salt. Sodium atoms bond with chlorine atoms in a precise ratio of 1:1 to make the substance we know as table salt. Dalton's idea of fixed ratios laid the foundation for what we now call stoichiometry, the mathematical relationship between quantities in chemical reactions. Finally, Dalton's atomic theory emphasized that chemical reactions are the rearrangement of atoms. Atoms aren't created or destroyed in these reactions. They're simply shuffled around to form new substances. It connects to the law of conservation of mass. Matter can't just vanish. Now, were all of Dalton's ideas perfect? Not exactly. We later learned about subatomic particles, protons, neutrons, and electrons, and discovered that atoms of the same element can vary in mass due to isotopes. Science evolves over time, but that doesn't diminish Dalton's contribution one bit. His atomic theory laid the groundwork for modern chemistry, shaping our understanding of the universe at its most fundamental level. So the next time you pour yourself a glass of water, pause for a second to marvel at the atoms inside, and the man who first dared to imagine their existence.